Hey, hi guys, warm welcome and a big hi to all of you. Big hi to all of you. Warm welcome to Cat Mojos. Yes, we have taken this decision to do this entire course of QA for Cat in four groups. That is, we'll start with the foundation, then we will go to the intermediate, then we'll go to the advanced level of problem solving, and then we will look at the reinforcement. Right? Yeah. The timeline is roughly about 1.5 to 2 months for the foundation course, and maybe about 2.5 months for the intermediate course, and maybe about 2 months for the advanced course, and the rest 2 months or 3 months we can do the reinforcement. Right, along with this we will also start, maybe as we conclude the first phase, that is the foundation phase on the quant. So we'll be very well prepared to tackle the DIs, especially DIs and LRs. So we will take a look at we'll parallelly start the DI LRs along with the intermediate course, right? Because when we start doing the DIs, we kind of understand that a bit of understanding of the ratios, a bit of understanding of averages, a bit of understanding of the percentage profit loss, etc., would play a good role in understanding them and doing them much faster and better. Fair enough. That's the thing, and we are doing the first module out here. We divided the foundation on quant into four modules. The one of them is numbers, arithmetic, then algebra, and geometry. We broadly divided them into four modules, and we're doing the first module. Here we are with the numbers, and today I will speak to you about the units digit, how to find the units digit of an exponential number, that is a number of the form a raised to power b. Right, that's what I'm going to talk about, but from the background of cyclicity concept. Right, before I tell you what is the cyclicity concepts for the digits, so let me quickly introduce myself. Hey, I am Belvi Srinivas. I've been working in the test prep industry since 2007. That's about 14 years now. I'm a passionate teacher as well as a good counselor. So in the last 14 years I worked in various capacities with different organizations. As you can see on this particular deck, I did develop some good skills to train the students in the space of QA, DI and LR over this period of time. That's briefly about me. And if you're looking at some short counselings, or you are looking at you're looking at the brief interactions, or maybe the doubts, etc., you can log on to this particular channel. You can you can subscribe to one of these particular channels, particular Telegram channels, and you can reach out to me here. Not only I, there are many peers already who are also learning like you, and there can be some fair amount of peer interaction as well based on your understanding and requirements. Right, there we go. So that kinds of brings us into the little bit of announcements quickly. If you guys have any doubts with respect to the topics that you are learning, it could be quantitative aptitude, it can be DI, LR, or it could be the VA, RC. So whatsoever the doubts that you have, so if on the Unacademy learners app, or it can be app, or it can be a desktop app, or it can be mobile app as well. Right, when you log in, so on your dashboard, you will find the doubts, ask a doubt feature. Right, this is the feature, ask a doubt. The feature is called as ask a doubt. So go to that ask a doubt feature, and then you can plug in your doubts, and it is kind of self-navigating tool. There is no big deal about it. And then you can choose the language in which you are looking for a response. Are you looking for a response in English or Hindi or some other language? Whatever the languages that are available, you can plug in those particular languages. Sure, so you'll get an answer as soon as you could for the questions that you're posted there. Right, yeah, that's one of the features that you can kind of make use of, because as you start preparing, I'm sure you get a handful of doubts. The point is, how do I go about the doubts could be sometimes a question, right? Sometimes you get a written answer, sometimes you do get a video solution based on the complexity or the difficulty level of the concept or the question that you have posed. Fair enough. So that's one feature that you can make use of, just in case if it is not getting reflected, then your app version may be a little different. You may have to refresh your app, in a sense. Probably you may have to go to the Play Store if you are on the mobile Android. Then you may have to you may have to reinstall that particular app once again to see the new features. Fair enough, right? That's the one. And if anybody has taken CAT 21, right? If you have taken CAT 21, based on your CAT percentile, you can enroll for this particular program called as a CAT Champions program. Okay, what happens there? Based on your CAT percentile, you can win rewards up to 10 times of your subscription, right? Whatever the subscription fees that you might have paid, you can get up to 10 times of that as a back. All right, now that might come as a reward. Right, just look at this MBA champions and enroll yourself for MBA champions. All right, so that brings us to the lecture. So here we'll start with the lecture. Let me quickly explain what is the cyclicity. Simple. Say it's for example, let us assume that today is Sunday. Let's assume that today is Sunday. Right, for example, let's assume today is Sunday. If I ask you that, hey, what would be the seventh day, or what would be seventh day from today? Very simple. Seventh day from today is back to Sunday again, because week has 7 days. Because for everywhere, you know, cyclicity. This is what I mean by the cyclicity, right? So similarly, if I ask you that, hey, today I am on Sunday, what would be the 16th day from today? Right, what would be 16th day from today? What do you do on this? So you look at this number 16. I'll let you take this number 16 and you will divide this by 7. You list the remainder. What is the remainder here? 2, which means it is 16th day from today is as good as saying 2 days from today, right? So you are on Sunday, 2 days from today. 16th day from today is as good as saying 2 days from today, right? 2 days from today, which becomes Tuesday technically, right? Monday, Sunday, Monday, and then Tuesday. That is the second day from today. Now second day from today is as good as saying the 16th day from today. What is that concept that I am using? Cyclicity as a concept that I am using. I should know the cyclicity beforehand. That's a point. If I don't know that the cyclicity for the weeks, all right, weekdays of a week is not is 7. If I don't know that concept, then I can't help that. Then I will not be able to find out what is 16th day from today quickly, right? So rather I would have taken much more time. So if I know that, okay, the cycle weekly cycle is just 7 days, so therefore I will simply divide by 7 and it comes to the concept of remainder, right? Concept of remainder. Now let's say that, hey, what would be 125th day from today? Fair enough. So you look at this particular number, you're talking about 125th day, 25th day from today. So we know that the cyclicity is just 7. So divide this by 7. You look at this 125 and you kind of divide this by 7 and list what? I'm interested only in the remainder. 7 one time. 7 in the sense I am dividing this 125 by 7. 7 1 times 7, therefore you have 55, right? Therefore you say that 7 times is 49, and hence you say that 6 is the remainder, right? 6 is the remainder implies what? 6th day from Sunday, which is 6th day, right? Technically 6th is the remainder, as good as saying 125th day from today, today being Sunday. So 125th day from today is as good as saying 6th day from today. 6th day from today is Saturday. You can count 6 days from Sunday, that is Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. It's going to be Saturday. This is what you mean by this. Can I say the same thing? Say this. Now we are in the month of December. Let's say we are in the month of December, right? If I say that, hey, what would be the 16th month from this month, right? What is going to be the 16th month from the December? 16th month from December. We know the cyclicity for months, right? In a months of the year. So what is that? It is 12. 6, therefore you take this 16, you divide this by 4 and divide this by 12, and the remainder is 4. That is, what is the remainder? Remainder is 4. What do you mean by this? 16th month from December is as good as 4th month from December. Cycle. After December comes January, February, March, April, and hence you say that my answer is nothing but April. 16th month from December is April. It's as good as saying 4th month from December is also April. So what did I know here? Again, I knew the cyclicity. Cyclicity for the months of a year is 12. Cyclicity for the days of the week is nothing but 7. Likewise, now what we are going to do is we'll jump into the digits. So now let's examine the cyclicity for these particular digits and we get into the problem after that, right? This is the concept of cyclicity. Just to put it to perspective, what you meant by cyclicity, I explained it to you, right? This is the meaning of cyclicity. Fair enough, my friends. So here we go. So let's go to the concept of cyclicity for digits now. Let's get on to the digits portion of this. We know that, hey, when we look at the digits, cyclicity to find what? Units digit. Concept of cyclicity to find units digit, only units digit. units digit of a raised to power b, a number of the form a raised to power b. How to find the units digit? Because we can find tens digit also, we can find hundreds digit also, but there are different algorithms. Cyclicity is a concept used for, broadly used for units digit. Hey, can I use cyclicity for tens digit also? Yes, but there are different better tools to do that, which we will do it at the intermediate stage of our learning, right? Yeah, so units digit of a raised to power b is what we are looking at, because cyclicity is a very simple concept, as I told you, very fundamental concept. Fair enough. Let's take a look at this. A raised to pi. What are the digits therefore? The units digit is nothing but the units digit of a. What can be the units digit of a? Forget the power for the time being. A is the base of the number. What is the units digit? What can be the values units digit can take? It can take 0, it can take 1, it can take 2, it can take 3, 4, and so on up to 9. Well, these are the 10 different units digits my base of the number can have, right? Okay, now let's examine something. Let's take 2 as a sample case. Let me take 2 as a sample case, and let me examine what do we mean by the cyclicity for the units digit alone, right? Let me write it like this. I'm examining it for 2. Okay, so when I'm writing it for 2, I will write it for 2 raised to power 1. So I'm continuing this particular cycle. 2 raised to power 1 unit digit is 2, right? 2 raised to power 1. 2 raised to power 1. Let me write x raised to power 1. X in this case is nothing but 2. 2 raised to power 1. Let me write only units digit, that is 2. Okay. X power 2, that is 2 power 2. The unit digit is 4. X power 3. What is the value of x here? This 2. Alright, I'm talking about this 2 here. 2 raised to power 3. Unit digit 8. X raised to power 4. That is 2 raised to power 4. Unit digit is 16. Nothing but unit digit is 6, because x 2 raised to power 4 is nothing but 16. Right? Yeah. X raised to power 5. That is 2 raised to power 5. 32. 32 is nothing. 32 nothing but unit digit is 2. Okay. X raised to power 6. Therefore, you would say that that's nothing but 2 raised to power 6, which is 64. So 64, the unit digit is nothing but 4. What you started seeing here. Now look at this. There is a 2, 4, 6, 8. Again, you got 2 and 4. If you want to continue this, you can write x raised to power 7, which is 2 raised to power 7, 128. You get this 8 back again. If you want to write x raised to power 8, that is 2 raised to power 8, right, which is nothing but 2 over 256. Therefore, it is back to 6. Now look at this cycle. Cycle is 4, 2, 4, 8, 6, and again 2, 4, 8, 6. If you continue this journey, again you will get 2, 4, 8, 6, which means the cycle is repeating after 4 stages, right? Cycle is repeating after 4 stages. Let me examine one more number. Let me take a number called 3. Let me take a number called 3. Let me examine this. So now the x value is nothing but 3 in this case, right? Here x power 1. X value is nothing but 3. 3 power 1, unit digit 3. 3 square, the unit digit is 9. 3 cube, the unit digit is 7. Why? Because 3 cube is 27. 3 power 4, 81. Therefore, that is nothing but 1. So you may say that, sir, I don't know from 3 power 5 onwards. No worries. So you are already at the unit digit of 3 power 4. The unit digit of 3 power 4 is already 1. Right? So if you want 3 power 5, what you should do? You should multiply by this 3. Therefore, multiply 1 also by 3. You get this 3 again. So nothing but 243. Those who know 3 raised to power 5, it is 243. Therefore, you say that back to 3 again. Right? Now 2 raised to power 6, or 2 raised to power 3 raised to power 6 is what? Next number. You say that, hey, you already know the unit digit of 3 power 5, which is nothing but 3. Multiply this by another 3. Nothing but this 3 into 3, which becomes 9. So those who know 3 raised to power 6, you know that that is nothing but 729. Therefore, the unit digit is nothing but 9. Simply, all it now. So let me examine this. Hey, is the cycle start repeating after 4 stages? Yes. 3, 9, 7, 1. And again 3, 9. If you continue this journey, again you will get 7 and 1. That is what it means to us. Okay, so now you kind of know cyclicity for, so you know you can say that, sir, which means cyclicity for every digit is 4, because that's the next doubt that you get. You may say that, okay, is the cyclicity for every digit going to be 4? Because you did 2 sample sizes, you did for 2, you did for 3. So is it going to be 4 for everything? Let's see. Let's take 4 as an example now. Let's take 4. Hey, what is 4 power 1? The unit digit is 4. What is 4 square? All right, nothing but 16. That is nothing but 6. Hey, what is 4 cube? 64. Okay, that is 4. Right? What is 4 raised to power 4? The 4 raised to power 4, which is 256. Right? Which is nothing but 6 again. Oh, okay. So which means cycle is only 2, 4, 6, 4, 6. right? Just 4 6 4 6, which implies that hey, cycles can be different, right? For different digits the cycles can be different. For 2 and 3 the cycle is 4. Cyclicity for digits 2 and 3 is 4. Cyclicity for 4 looked like, call it now, look like only 2, that is like 4 and 6 4 6 4 6. It oscillates between 4 and 6. It is flipping between these two numbers. Take another example, for example 9. So let me take it for 5. Let me take it for 5 here. Yeah, what's happening for 5? So if you look at 5 power 1, 5. 5 square 25, 5 square 25, 5 cube 125, 5 again, 5 power 4 625, 5 again, oh, which means the cycle is single 1. Call it cycle is 1, which means 5 raised to any power it is going to be 5, except 0 of course, right? 5 raised to any positive power it is going to be 5. Cyclicity is 1. Okay, we examined 3 different things. In fact, the cyclicity for any digit has to be one of them. That is, there are certain digits which have a cyclicity of 4. There are certain digits which have a cyclicity of 2. There are certain digits which have a cyclicity of 1. Okay, how many digits I have? I have 10 digits. Alright, in the sense the units digit can take 10 digits. That is 0 to 9. There are 10 digits. The 10 digits can be classified into 3 groups. What are the 3 groups? There are certain digits which have a cyclicity of 4. There are certain digits which have a cyclicity of 2. And there are certain digits which have a cyclicity of 1. There is no digit which has a cyclicity of 3 or which has a cyclicity of 5, etc. There are no such digits, right? So it belongs to one of these 3 classifications, one of these 3 bins. All right, okay, which are those particular digits? The digits 2, digit 3, digit 7 and digit 8. Now these are the 4 digits which have a cyclicity of 4. Which are the digits? 2 3 7 8, out of which I have shown already for 2 and 3 out here to you, right? 2 and 3 I have kind of shown it to you. 2 and 3 have a cyclicity of 4. Not only 2 and 3, even 7 and 8 also have a cyclicity of 4. All right, which are the digits which have a cyclicity of 2, right? The cyclicity of 2, one of them is 4, which I have already shown to you, right? Cyclicity of 4, 2 is nothing but 4. The other digit is nothing but 9. These are the only 2 digits. How to remember? Easy to remember. 4 and 9 are perfect squares, right? 4 and 9 are perfect squares. No big deal. It's kind of easy to remember, right? Okay. So there are only 2 digits. Okay. What about the rest of the digits? Then they have a cyclicity of 1. Which are those digits? The number ending in 0 raised to any power is 0. That's 0. And then 1 raised to any power is 1. Then you have 5 raised to any power is 5. And 6 raised to any power is 6. We covered all 10 digits there. You got to remember this executive summary, right? This particular summary you should kind of remember, because just like you remember for the calendar how you were able to find 125th day from today, because you know that the days of the week are 7, therefore you divided 125 by 7 and you found the remainder. Which means, sir, here also I'm going to find the remainder? Of course, yes, that's what we are going to do there. For that reason you should know the cyclicity for every single digit. I hope you are following what I'm trying to say there, right? Yeah, this box, what I put it here, you should by heart this particular box. There is no choice in the matter, right? You need to by heart this particular choice, you need to by heart this. Good. All right, so now let me take another point from here. Let me illustrate that, because some of you may be wondering where is the remainder here. You said that you have to take a remainder to figure out some things like that. Let me take the 2 power only as the example, right? Let me take that. Hey, what is this you are trying to say? The unit digit of cycle is 4. Let me write first cycle here. Let me write the cycle 1. 2 power 1, 2 power 2, 2 power 3, 2 power 4. Hey, what is the units digit of these particular powers? Let me write it here. Unit digit is 2, unit digit is 4, unit digit is 8, and the unit digit is 6. Okay, this is one cycle. Now let me write the second cycle. Like Sunday, Monday up to Saturday, second cycle. You write 2 power 5 here. What is the meaning? The unit digit of 2 power 5 is also 2. Unit digit of 2 power 5 is also 2. Then under this I will write this row 2 power 6 I will write. What is the meaning? The unit digit of 2 power 6 is also 4, right? Then I will write 2 power 7 here. I write 2 power 8 here, which means the unit digit of 2 power 8 is same as unit digit of 2 power 4, which is nothing but 6. Okay, the third cycle I will write here. The unit digit of 2 power 9 will be same as 2 power 5, which will be same as 2 power 1, which is going to be 2 there. Similarly, unit digit of 2 raised to power 10 will be same as unit digit of 2 power 2, which is going to be 4. In the sense, hey, I just have to figure out that when the large number like 2 raised to power 10 is given, I should say, does 2 power 10 belong to the category of 2 power 1, or does it belong to a category of 2 power 2? Does it belong to a category of 2 power 3, or or does it belong to a category of 2 power 4? Hey, what does it mean to us? I just have to remember that cyclicity is only 4. Whatever the numbers I'm going to say, even if I say 2 power 7, it should belong to either 2 power 1 group or 2 power 2 group or 2 power 3 group or 2 power 4 group. It should belong to one of these 4 particular groups, because the cyclicity for 2 is 4, as we already examined. That's a point there. Now how do I find out 2 power 10 belongs to which groups here? So if this is my number, 2 power 10 belongs to which particular group? How do I understand this? Very simple. Take the power 10, take this particular power 10, take the power 10. You know that a cyclicity for 2 is 4. That's a point that you will know. You have to look at the base. The base number is 2. The cyclicity for 2 is 4. And then you look at this 10 as the power. You divide by the cycle. So 10 divided by 4, list out what is the remainder. Remainder when 10 divided by 4 is 2. It implies that the unit digit of 2 power 10 is as good as 2 power 2. Here is the 2. It is as good as 2 power 2. Let me examine, hey, what will be the unit digit of 2 raised to power 50? What would be the unit digit of 2 raised to power 50? For example, unit digit of 2 raised to power 50, simple. You look at this 2. First you have to question yourself, do I know the cyclicity for this base? Yes, cyclicity for this base is 4. Now take this number 50. What is that? Power 50. Divide this by 4 and list out the remainder. 48 is divisible by 4. Therefore, the remainder is nothing but 2. You say the 2, which implies that the unit digit of 2 raised to power 50 is as good as unit digit of 2 raised to power 2. You don't have to by heart what is 2 raised to power 2. That comes naturally. Nothing but 4. This is how the steps translate in your mind. This is the meaning of cyclicity, right? This is what it means to us. Okay, let me take another example here. What is the unit digit of 2 raised to power 547? Simple, guys. Okay, you look at this 2 here at the bottom denominator. Sorry, base. Unit cyclicity is nothing but 4. You look at this particular power 547 to be divided by 4 to figure out what is the remainder there. Again, what is the divisibility rule for 4? I spoke in the divisibility class at the beginning of this particular journey, not this particular lecture. I already did 2 lectures on basics of divisibility, one on divisibility, one on divisibility algorithm, isn't it? Please go to that video just in case you are not clear about what I'm talking. Divisibility for 4 is nothing but the last 2 digits, which implies even while I'm finding the remainder, ignore this 5. 47 divided by 4, the remainder is 3. Therefore, you say that, hey, 2 raised to power 547 is nothing but as good as finding the unit digit of 2 raised to power 3, which is nothing but 8, nothing but my answer. Okay, that is the beauty behind this particular cycle, right? That is the reason we are trying to understand, already we are trying to understand the cyclicity. Look at this example. Already you look at the 2 raised to power 254 when you wanted the unit digit of 2 raised to power 254, just because you know the cyclicity for 2, hardly in about 2-3 steps or few seconds, maybe about 20 seconds or 30 seconds, you are getting the unit digit of this particular number, which is so very easy. Fair enough. Alright, now that sets solid for the next level of our discussion. This is the one portion of our discussion with this particular summary, which you got to kind of remember. You got to remember this particular summary. Okay, let me quickly explain what it means to say that the cyclicity for certain numbers is 2. Let me take this example to illustrate one of my points here. Say for example, cyclicity for 9 is 2. What does it mean? It simply means that 9 power 1, well, it is nothing but 9, right? 9 power 1 is nothing but 9, and 9 power 2 is nothing but 9 power 2 is nothing but 1. So unit digit 9 power 2 is 81, therefore it is 1. Simply implies that a 9 power 3 is same as 9 power 1. 9 power 4 would be same as 9 power 2. 9 power 5 is same as 9 power 1. 9 power 6 will also be same as this. What is that you are trying to say? Okay, simply 9 raised to every odd power, the unit digit is going to be 9. The 9 raised to any even power, the unit digit is going to be 1. Right? That is what you mean by having a cyclicity of 2. Now, I don't think cyclicity being 1, no explanation is required. For example, let me take this number 6. What you are trying to say is 6 raised to any power other than 0, the unit digit is always going to be 6. What can be any natural natural number, right? Any natural number, the unit digit is always going to be 6. 6 square, 6 cube. Just think about it. Whatever the numbers that you know, you understand that, yeah, that's true, right? What we are talking is that. All right. So that sets it for another important exploration. Probably we will try and see, or if we can learn a little bit about that. Let's take a look at this. Listen to me. All right, listen to me. Let me quickly brief you another important thing, another part of the summary before we get on to the problem solving. Yeah, so here we go. So now let's examine this. So we can summarize this entire cyclicity at fourth stage, right? At the fourth stage. You may wonder, sir, why at the fourth stage? Simple. Some of the digits have a cyclicity as 1. Some of the digits had a cyclicity of 2. Some of the digits had a cyclicity of 4. Hey, what is the LCM of 1, 2 and 4? LCM, right? Least common multiple of 1, 2 and 4, which is nothing but 4. And hence we can kind of summarize this at the fourth stage. In what sense? All right, let's take a look at this. All right, in what sense? Let's take a look at this. Let me write all possible even numbers to start with. The fourth stage of the sense, you have x bar 1, you have x bar 2, x bar 3 and x bar 4. Guys, you got to remember this. Why I'm saying this is that there is a summary that I'm going to give after this, which is worth remembering. So I'm taking you through this particular ordeal, this journey, so that you kind of remember it well. All right, the amount of time that you spend will ensure that you kind of go on to remember this. All this, the high school stuff, right? Yeah, some of you might have done in the 11th standards, which whatever the area it could be, but somewhere around 9th, 10th, 11th, you find all these kind of cyclicity concepts for the digits, etc. Fair enough. Let me take a look at the all even numbers. 0, then I have 2, I have 4, I have 6 and I have 8. Now let me write this entire 4 number series for this. All right, 4 number series for this. Hey, 0 raised to any first power 0, 0 raised to power 2, 0 raised to power 3, 0 raised to power 4. No brainer. Hey, I'm just consolidating at the fourth stage. Okay, what about 2? So you say that 2 square 4, 2 cube. All right, now here I'm looking at this 2 cube like this. I'm looking and I'm writing it under this particular box here, right? Yeah, 2 cube, nothing but 8. 2 raised to power 4 is I'm looking this 2 and then I'm writing it under this particular box, right? Yeah, so therefore 2 raised to power 4 is nothing but 6. All right, 4, 6, 4, 6. All right, now let me go to 6. Hey, everything is 6. All right, everything is 6. All right, therefore let me go to 8. Right, you say that 8 square 4 and then 8 cube. All right, 8 cube. All right, now which is nothing but 2. All right, 8 cube ends in 2, that is 512. Right, 8 raised to power 4, 8 into 2, which is nothing but 6. Okay, now this completes my even number cycle. Right, this kind of completes my even number of cycle. What is that you are observing? The domination of 6. Look at the amount of domination of 6. Exception being only this particular 0. You leave that 0, the unit digit of fourth power of even number is always 6. So that is what I want you to kind of remember in the part of the next part of the summary. Right, we understood one part of the summary, which digits have a cyclicity of 4. The second, what we are trying to understand here is, hey, units digit of fourth power of an even number, even, all right, that's a base, all right, base being an even number. Fourth power of an even number is 6. Unit digit, not complete number, right? Unit, U stands for unit. Unit digit of fourth power of an even number is 6, except the number ending in 0, right? Except the number ending in 0. Fair enough, right? 0 raised to any power is 0, all right, which we kind of know, so no brainer there, right? So we leave that particular number there. Right, let me come to the odd numbers here. Let me come to the odd. Okay, this is the story of the even. Say, what if it is a story of odds here? Let's write for the odds here. Let's say 1, 3, 7, 9 and 5. Let me write it like this. All right, 1, 3, 7, 9 and 5. These are the five odd digits. All right, let me write the cyclicity for these folks as well. Hey, 1 raised to power 1 is 1 here. 1 raised to power 1. So I'm coming and writing it under this, right? Yeah, 1 raised to power 1 is 1. 1 square, 1 cube, 1 raised to power 4. Good. All right, then 3. All right, 3 power 1, 3 power 2, 3 power 3 and 3 power 4. 7 power 1, 7 power 2, 7 power 3 and 7 power 4. What I'm writing? I'm writing the unit digit of all these powers. 9 power 1, 9 power 2, 9 power 3 and 9 power 4. 5 power 1, 5 power 2, 5 power 3, 5 power 4. What do you see here? Again, the dominance of ones, right? Domination by ones, exception being this particular number called 5. So what is the summary that you would like to write? Therefore, you say that, hey, unit digit of odd number raised to power 4. Unit digit of odd number raised to power 4 generally results in 1, exception being 5, right? Exception being 5. 5 is the only exception where the unit digit is going to be 5. Otherwise, you take any odd number, it is going to be 1. This is the second part of the summary I want you to remember. Hey, what was the first part of the summary? The digits having the cyclicity of 1, which we know. All right, what are the digits there? The digits are 0, 1, 5 and 6. Okay, what are the digits which have a cyclicity of 2? Perfect squares, right? Single digit perfect squares other than 1, that is 4 and 9. Okay, what about the remaining digits? That is 2, 3, 7, 8. They had the cyclicity of 4. This is one part of the summary I wanted you to remember. This is the second part of the summary I want you to remember. Now this is all about the cyclicity. You need to by heart both these charts, right? Both these charts. You should know which digits have the cyclicity of 1, 2 and 4, and you should know what is the units digit of the fourth power of the even number on the odd number, right? So this is the kind of summary which puts to perspective. Let's now get into the problem solving. I hope you are enjoying what I'm trying to say, and since in the sense you are learning all it quickly, you are kind of revising from the high school, because yes, you might have remembered these facts from your high school, and then you could have conveniently forgotten this as well. All right, very clear. So for example, social studies, right? I forgot most of the social studies, be it geography, be it history. Yeah, we kind of knew that. All right, now when the monsoon comes from the when it comes from the southwest, all right, when it comes from the southeast, right? Now how the waves are formed, clouds are being formed, how the wind blows those clouds, and therefore the rain in India, all that stuff. But yeah, but I kind of forgot the timelines for them, right? So because it's a long time back. Similarly, same thing might have happened with most of us with respect to math as well, just being out of touch. No need to panic. It is already today. If you say that, sir, everything is looking Greek and Latin, right? You look at this, hey, what is this kind of summary? I don't remember doing something like this. You look at this, say, what is this kind of summary? Don't remember looking at like this. No, you could have definitely looked at this. You might not remember it today. That is it, right? You might not remember some of them today. It is past your memory. No worries, that's what we are trying to do. It's a very simple stuff. Okay, let's come in now to the problem solving based on this. Some of them could be kind of exam level problems also, which appeared in exams like CAT and other management entrance exams, right? Some of them, but then most of them is to ensure that our foundation is clear with respect to this particular skill, more to do with the foundational area of it. Let's take a look at one of the examples. Now, having understood this, in case if you have not, I'll quickly note down these 2 points here. Note down these 2 points in your sheet of paper. So I'm hoping that everybody is sitting with a book and a pen, which is very important virtue while learning. Don't be a passive listener. That is not going to help, and it's going to kill your time. So keep a book and keep a pen. Whatever the little things that you don't know, always quickly try to note this down. You don't have to come back to this video again and again and again. Not required, right? That's a waste of time. So when you do it once, do it meticulously during that time itself. That always pays off well, so that you create time for some other activity. Right, good. Yeah, here we go. Here we go. The unit digit of this particular number is what? Okay, so now we see a number 683475. So what I need to know, the tens digit does not contribute. Let me rewrite this. 68 raised to power 3475. Okay, so I need to know all it because I'm finding the units digit, right? When I'm finding the units digit, this 6 does not contribute. The tens place does not contribute to the units place, right? Yeah, only but units place can contribute to tens place in the form of a carry, etc., right? But then tens place would never contribute back to the units place. Therefore, 6 is ruled out. Second one, the question that you ask is what? Hey, do I know the cyclicity for 8? That is the question that you are going to ask. Yes, the cyclicity for 8 is 4. Therefore, what I should be doing, I should look at the power, which is 3475. I divide by the cycle to find out what is the remainder. Now while I am doing this, I don't even have to consider, once again, I don't have to consider 3 and 4. You may wonder, why not, sir? What is the problem? As I told you already that, hey, the divisibility rule for 4 is last 2 digits. Therefore, the remainder also comes from the last 2 digits. If the number is 3475, you can safely ignore that 34. Hook on to the last 2 digits. Don't look only at the last digit. digit, last two digits. You should go by the divisibility rule function, right? Okay, 75 divided by 4, the remainder is nothing but 3, right? Remainder is nothing but 3 because 72 is divisible by 4. And then you say that, okay, my given function is equivalent of, that is unit digit of 8 raised to power 3475 is as good as unit digit of 8 raised to power 3. Here, that remainder, 8 raised to power 3. Now, 8 raised to power 3, you might have to do it little mentally there, right? Which is nothing but 2, right? 8 raised to power 3 is the unit digit is nothing but 2, which is going to be my answer. Very, very simple way of dealing with this. No big deal. You have to see what digits matter, what digits does not matter. For example, here the 6 does not matter, 34 does not matter, right? They may look like giving a large number, but the point is it only few digits matter, few of the digits do not matter in the given problem. Okay, I kind of understand that you could kind of get this particular point there. So let's move further, but before I go further, let me quickly introduce you to some of the programs offered by Unacademy. So allow me to do that quickly. Yeah, on 29th, all now there are few fresh batches which have launched. If you are appearing for CMAT, one particular batch is designed for CMAT, and there is another batch which is nothing but the percentiler batch. Now it's given that it's a basic, which means the course kind of starts from the basic. Now these are structured courses, right? These are the structured courses on the Unacademy on Unacademy learners platform. These are structured courses. What do you mean by structured courses? If you go to and listen to the videos uploaded by them, in a sense there will be a short 3 to 5 minutes video uploaded by these 3 educators. If you go and see, they would say that in what level. For example, let's assume that one of the educators is teaching you QA. That person would say that how he is want to go about this particular course of QA. What is the objective of this particular course? How the person wants to deal with this particular course in the coming month or so, right? So they might start with level 0, then go on to the level 1 and stop the course at level 1, and then there is another batch which starts at level 2 and goes to the level 3 kind of, or it can be the same course which can continue with this. Likewise, now you can find out, for example, if you are not so good in RC, let's say that, okay, there is a RC course the professor is conducting. So if you are not so good at RC, now always look for a RC course which starts at level 0, because you are not so good at RC, you felt that, okay, that is one skill probably I have to build from the scratch. I have not been a very good reader. Fine, in that case you may have to start from the scratch, that is level 0, right? What kind of books to read, you need guidance from there, and how to read, how to look for the central idea, how to look for the evidences, all that stuff you might have to read you might have to learn from the scratch. Therefore you might have to look for that kind of batch. On the other hand, let's assume that, hey, I'm very, very good at RC, then you better look for a batch which is RC starting at the intermediate level or advanced level, right? Likewise, at the Unacademy platform, you will find the batches being launched every single week with different objectives. It is not that every batch has the similar objective. Every batch has a kind of a different objective because it caters to different kind of learners. The point is the frequency. Every week batch launches being there, you will always find something that is of your interest, that will help you to enjoy, help you to grow from one level to another level in that particular skill area. Fair enough, that's what you mean by this. But how to become a part of this? You might have to go for a small subscription fees, right? These are the subscription fees for 6 months course, 12 months course, 18 months course, and 24 months course, right? These are the subscription fees. On all these subscription fees, you get 10% discount. You get 10% discount when you use any of the educator code, including my code, which is Belvi 100, right? Belvi 100 doesn't mean that you get 100% discount. You get 10% discount, which means an annual subscription would be this. In the sense, you get the course material, you get the test, you get the lectures, all of this about 20,000 per annum, right, for one particular year, right? Okay, so that's how you become a part of this particular plus subscription. But my preference has always been the iconic. So if you are seriously preparing for CAT and other management entrance exams, I would rather suggest you to go for the iconic subscription. So what is so special about this? In the iconic subscription, you will get one-to-one interactions. You will get one-to-one mentoring with the mentor of your choice, right? So what does it mean to us? So in 6 months, you will get 25 25 one-to-one interactions. You can avail in 6 months. 26 months is technically 26 weeks, right? In 26 weeks you can avail 25 one-to-ones. One-to-ones means what? One-to-one interactions. You come out with an agenda. It is not the faculty who comes out with an agenda, it is you come out with an agenda. Your agenda can be as simple as, right, how should be my study calendar for the month of Jan, right? You can sit with the faculty and you can say that, sir, I'm studying in a college. Now this is the kind of calendar I have in the college. These are the kind of assignments I might have to do, or these are the internals, or these are the exams. Between this, now how do I go about my preparation for CAT? This is my profile. This much I know from Quant, this much I know from RCs, or I'm not a good reader, I'm a very good reader, whatsoever it could be. Therefore, how should my preparation calendar should look like? What books I need to kind of follow? So that's kind of a discussion you might want to have. Come another month, you might want to have another kind of discussion saying that, hey, I reached this particular level, but I'm facing difficulty in these particular areas from the last month. How should I go about them? You can take a doubt solving with the faculty in that time, or you can take some concept discussions with that particular faculty in that time, and then you can set up the agenda for the month of Feb. Exams come in, you can look at how do I approach the exams, what should be my strategy, knowing my strengths and weaknesses, knowing my background, how should I approach the mock exams. So from there, how to improve the mock exams, and so on and so forth, various other things. That's what you kind of do in these 25 one-to-one interactions with the mentors, right? Similarly, if it is a 12-month subscription, you get about 50 one-to-ones, and here you get 100 one-to-ones. If it is a 24, yeah, these one-to-ones are a big help. Trust me, having the conversation with the right people to help you definitely in your preparation, and that frequency is also very important. You may wonder, hey, why 25 one-to-one interactions? Because in the online space, you tend to miss to speak to the faculty. If it is a classroom, every day you are seeing the faculty, anytime you can have that kind of discussion, but here it may not be possible, and hence 25, the agenda being at least one per week kind of stuff. Yeah, so but these are the subscription fees. On this subscription fees also you get 10% discount whenever you use the educator code, including my code, which is Belvi 100. All right, yeah. So but then as of now, there is an offer going on in a 6 months. Just now I said that 6 months you will get 25 one-to-ones. It is not 25, it is going to be 35. You buy all it during this offer period in the next couple of days, you will also get 35 one-to-ones, all it, which is 40% more. This is 40% higher than this 25 to 35, right? Similarly, in a 12-month subscription, we said that 50 interactions, but in 1 year you can have 70 interactions, which is better. You can have multiple interactions in a week because there are 52 weeks in a year, but up to 70 interactions are possible, right? So something like that, where you panic sometime, you just call up, or you can set up a meeting with the faculty or a mentor of your choice, and then quickly have a discussion with that person. Fair enough. Now these are the benefits of Iconic. Therefore, I would always suggest that, hey, go for an Iconic, which will definitely help you to move from one level to another level of progress much faster. Right, good. All right, now that brings us back to the lecture again. Let's come back to the lecture. That's about the announcements, and here we are back to the lecture. Now let's try and answer this particular question. Do it with me. Do it with me. Let's try and answer this particular question. First, let's understand what matters, what does not matter. 3 matters. 3 matters, 7 and 5 does not matter, 7 and 5 does not matter, this 5 does not matter, only 59 matters. You may wonder why so? So because the cyclicity for 3 is 4, and the divisibility rule for 3 is divisibility rule for 4 is nothing but this. And hence what you say, you look at this 59, you take this power 59 and you divide this by 4, and you will list out the remainder. You will list out the remainder, which is 3. Therefore, the unit digit of this is nothing but as good as 3 raised to power 3. Okay, what is the unit digit of 3 raised to power 3? 7. That is one side of the story. Good. All right. The second side of the story. Now, what does not matter? 8 does not matter. 5 does not matter. Right? This 5 also does not matter. 3 also does not matter. You may wonder, what is the problem? How come 3 also does not matter? Because the cyclicity for 9 is 2. So what is the divisibility rule for 2? Units digit, right? Divisibility rule for 2 is units digit. Therefore, it is as good as in your mind. In the sense, you don't have to write those steps. You are seeing what to see, what not to see. In the sense, a number is presented 8, 5, 9, 5, 3, 7. What my eye should be seeing, that's important. Your eye should be looking at this 9 and this 9. Rest of them does not matter. That's how I'm trying to say. So, what to see, what not to see is a choice, right? What to see, what not to see is a choice, right? Okay, this is as good as writing 9 raised to power 7. I just told you that 9 raised to any odd power is nothing but 9 raised to power 1. You can say that also. I will take this 7, divide this by 2, list out the remainder. Remainder is nothing but 1. In the sense, it is as good as finding the unit digit of 9 raised to power 1. Fair enough. Figure that out, which becomes 9. Okay, what I should do between them? There is a multiplication symbol. Multiply the unit digits, write down the final unit digit. 9 into 7, 63. Therefore, only the unit digit you can capture. 9 into 7, 63. Unit digit is 3, which is going to be my answer. Which is my answer. Very simple question. What is that we are trying to say? Hey, we should know the kind of divisibility rules for the numbers. If I know the divisibility rule for number, I should know where to look at. If I know the divisibility rule for 2, I should know where to look at. There may be some unnecessary elements, but you should know what are the necessary elements of the problem, what may not be unnecessary elements of the problem based on our understanding, because we already know the divisibility rule, then kind of make use of it, right? That's the whole point there. All right, come back. Let's come to the next question here. Find the unit digit of this particular number, right? Find the unit digit of this particular number. Again, already you kind of understand that these two 2's does not matter, this 3 does not matter. This is as good as writing 2 raised to power 33 divided by 4. You may have said that, say, why sir you are suddenly doing 33 divided by 4? In your mind, that's what you do, right? So you look at this particular power 33, you remove the cycles of 4, and you say that, sir, this is as good as 2 raised to power 1, which is nothing but unit digit is 2. That's how it will translate in your mind, isn't it? Okay, yeah, what about 3? Now say again, unit cyclicity for 3 is nothing but, cyclicity of 3 is nothing but 4. Therefore you say that 3 raised to power 22 divided by 4, because it's a mental calculation. Although I'm writing it here for you to understand, but in your mind that's what you would be doing. You will be simply looking at the 22 and dividing by 4, and you would say that, hey, this is 3 raised to power 2 remainder, right? Because I already taught you how to look at that. 22 when divided by 4, 2 is the remainder. That's what you wrote there. 3 square is nothing but 9. So you are adding these two numbers. You are adding these two numbers. Yeah, why you are adding? Because there is an addition sign this time. Therefore you are adding 9 plus 2 is 11, which means the unit digit is nothing but 1. All right, unit digit is nothing but 1 for this number, because we are kind of trying to find the unit digits here. It's a matter of cyclicity, in the sense when you look at the base, the number in the base, you should know the cyclicity for that particular base, right? Okay, I hope you are all learning here. Let's take a look at this particular question. I will give a pause. I will give a small short time of about 30 seconds. Why don't you think about this particular question? Think about this particular question. I will pause for 30 seconds. I'll pause for 30 seconds. What do you think about this? Yeah. Okay, you may be wondering, sir, you are talking about the units digit. What happened? Suddenly you are now talking about tens digit, right? The digit in the tens place, because the digit in the units place is 0. Therefore, the digit in the tens place is nothing but the first non-zero digit in this particular question. You may wonder how. But let's take a look at this. Okay, here I will rewrite this as 2 raised to power 36, another 2, and 5. So I only rewrote this particular fashion. This 5 I wrote it as it is. 3 raised to power 27, I have split it as 3 raised to power 26 into 2 raised to power 1, right? So 2 raised to power 36 and 2 raised to power 1. I kind of just split this part there. Fine. So what does it mean to us? So I multiply these two. 5 into 2 is nothing but 10. So then I have 2 raised to power 36. Say now, for example, let's say that instead of 2 raised to power 36, what if I had 2 raised to power 5 into 10? That known number, right? 2 raised to power 36 value we don't know. So 2 raised to power 5. Good. 2 raised to power 5 is 32 and into 10. Therefore, the number is 320. Hey, what is the units digit of this number, man? The unit digit is nothing but 0. Hey, what is in the tens digit? This is the units digit. That is 0. But author is not interested because he knows that the unit digit is going to be 0. And hence he is interested in the tens digit. What do you mean by tens digit? Tens digit is nothing but the unit digit of the non-zero part, right? Units digit of the number, in the sense, hey, this you leave it, this 10 you leave it here, because the 0 comes and sits in the units place. The 0 ultimately sits in the units place, and hence just find out that if you want the tens digit of this bigger number, it is as good as finding, don't get confused, right? Now be careful here, as good as finding the units digit of this particular number. Very good. So let me find that, and hence you say that, yeah, what is the cyclicity for 2? It is 4. I will take this number 36 in the power 36 divided by 4. You say that the remainder is 0. Now you get it. Oh man, remainder is 0. I never had this situation before. So what was this? What you know, the cyclicity for 2 is either the given number should be a part of 2 power 1 cycle, or it should be a part of 2 power 2 bin, or it should be a part of 2 power 3 or 2 power 4. Where is 2 power 0 between all this? There is nothing. nothing called as 2 power 0. We didn't even discuss 2 power 0 or 3 power 0 or 4 power 0. We never discussed about this. But suddenly you end up in a situation of remainder being 0. What does it mean? Remainder being 0, remainder being 1, right? Remember, remainder being 1 means equivalent of 2 power 1. Remainder being 2 means equivalent of 2 power 2. Remainder being 3 means equivalent of 2 power 3. Remainder being 0 means equivalent of 2 power 4. Because you will never get 4 as the remainder when you divide a number by 4. Think about it. Because you are dividing a number by 4. Will you get 4 as the remainder? No. Instead of 4, what do you get as the remainder? You get 0 as the remainder. That's a point we are trying to make. And hence you say that it becomes 2 raised to power 4. Whenever the cycle is complete, a 0 should be taken as 4, right? So in this particular case, and hence you say that okay, therefore 2 raised to power 36 is as good as 2 raised to power 4. It is as good as 2 raised to power 4. What is the unit digit of 2 raised to power 4? The unit digit of 2 raised to power 4 is nothing but 6. The unit digit of 2 raised to power 4 is nothing but 6. In the sense, if you look at the last 2 digits of this number, it appears last 2 digits are like 6 0. The tens digit is 6, the units digit is 0. That's how it looks, and hence the tens digit is nothing but 6 for this particular question. I hope, okay, I didn't make a mess out of this. You kind of understood what I tried to say. Now this is just an analogy, a minor example, just to understand that 10 means the unit digit becomes a 0. However, all at the same concept. Therefore, we kept this 10 outside. We focused on 2 raised to power 6, and we examined one of the important facets in this question, that is when the remainder becomes 0, how I need to understand. Because we never discussed the unit digit of 2 raised to power 0, 3 raised to power 0 or 4 raised to power 0. We never discussed as a part of cyclicity, but suddenly you found that the remainder has become 0. What does it mean? The remainder has become 0 means the cycle has come to an end. That is the last element of the cycle. In this case, it is 2 raised to power 4, because the cycle is going to begin again with 2 raised to power 5, 2 raised to power 6, etc. Right? The end of that particular cycle is what we are talking about. Just remember that whenever 0 comes as the remainder, you need to be a little mindful about it. Don't try to calculate 2 power 0 is equal to 1, therefore that is my answer. Right? Because you got a 0, then don't be all right now quickly go and say that okay, the base is 2, the power is 0, therefore the unit digit is 1. No, don't do that mistake. All right, that's a mistake. All right, so that sets it for the next example. Okay, I hope you are learning, learning here. That sets it for the next example. Okay, let's come to this. This was the cat question. This was a cat question, just that the power has changed. Yeah, find the rightmost non-zero digit. Rightmost. Now look at this, guys. This is the rightmost. If you write a number from this one end to another end, the rightmost digit is there and the leftmost digit will be here. So now what author is trying to say is, hey, find the rightmost non-zero digit. In the sense, you start searching from this side, there will be lot of zeros. There will be lot of zeros before you encounter a non-zero digit called as x. Before you encounter a non-zero digit called as x, right? There can be x, after that y, x, y, etc. are the digits here. Let's say, hey, what is the digit I'm interested in? I'm interested in this digit x, which is a non-zero digit. After all my zeros, there are a lot of zeros. There are a lot of zeros which will come. To be precise, how many zeros? 375 zeros. To be precise, 375 zeros. Take a look at this number. This is nothing but 13 raised to power 375 into 10 raised to power 375. What do you mean by 10 raised to power 375? There will be 375 zeros towards the end. 375 zeros it ends with. Alright, there will be trailing zeros. 375 zeros. Okay, yeah, 375 zeros. Then you are now nothing but a rightmost non-zero digit, means I just have to find the unit digit of this particular number. I am supposed to be finding the unit digit of this 13 raised to power. They say what matters? This is nothing but 3 raised to power 75. You may wonder what happened to this 1 and 3. It doesn't matter. That's what we said there, right? Okay, therefore we look at what is the cyclicity for 3, which is 4. Therefore you kind of divide this by 4 and you list down the remainder, which is nothing but 3 raised to power 3. 3 raised to power 3 is nothing but 7. 3 raised to power 3 unit digit is nothing but 7. That's how it kind of operates in your mind. You understand that, hey, this part doesn't matter. 10 raised to power 375 gives me the number of trailing zeros, successive trailing zeros, which would be 375 in number. Therefore, all it matters is I need to find the unit digit of this. This is how things translate in your mind to arrive at the answer, which is nothing but 7 in this case. Good. So that sets it for the next example, my friends. That brings us for the next example. Take a look at this. Take a look at this. Yeah. I will give about 20 seconds, 30 seconds. Just think about this. Yeah, good. I think you would have cracked it by now. Okay, what matters here is this. Hey, he says that, look, man, 3 raised to power n. So why I'm saying this? Because 7 does not matter, right? 7 does not matter because it's a units digit. Tens place does not matter. So therefore, 3 raised to power n, the units digit of 3 raised to power n is nothing but 7. Alright, that's is 7. Units digit of 3 raised to power n is nothing but 7. What matters? Only 4 things matter. I just have to check, will this be equivalent of 3 power 1? Will this be equivalent of 3 power 2? Will this be equivalent of 3 power 3? Will this be equivalent of 3 power 4? The n can take only 4 samples. As you may say that, sir, why not 3 power 5, 3 power 6, 3 power 7? Because the unit digits will anyway match. It's a cycle, man. It's a cycle. So why should I go for the second round of the cycle? First cycle only I will match. Therefore, I will pick the value of n from the first cycle itself. One of them, either it's equivalent of 3 power 1. No, because 3 power 1 is nothing but 3. What is 3 square? Which is 9. Hey, what is 3 cube? Which is 7. Right? Which is what is 3 power 4? 1. So what matters to me is this. Therefore, what is the value of n? The dummy, one or other, the smallest value of n is nothing but 3. Smallest value of n is nothing but 3. So therefore, go to this particular question. This 3 does not matter. You are trying to find the unit digit of 7 raised to power 3. You are trying to find, because you've understood that the smallest value n can take is 3. N can take many values. You can say that, hey, sir, n can take 7 also. Correct, but it really doesn't matter, because the same cyclicity is followed on the other side also, because you understand that it is again 7 power 1, 7 power 2, 7 power 3, 7 power 4. Same cyclicity 4 on the other side. But the point is, you need to know the value of n. You got the smallest value of n, which is nothing but 3. 7 raised to power 3, the units digit is nothing but 3. Units digit of 7 raised to power 3 is nothing but 3, because unit 7 power 3 is 343, which is nothing but 3 here. So that's my answer. Unit digit is nothing but 3 out here. Good. Simple way. Just that okay, they might have conned us by giving the power as an unknown, etc. It really doesn't matter. As much as I understand what is the cyclicity for that particular digits, we can always nail down those kind of questions. All right. That sets it for another question, my friends. That brings us to the another question. A 20 seconds time for you. Quickly think about this. Quickly think about this. A 20 seconds time for you. Yeah, okay. So here I need to go. The unit digit of, this is the starting point, right? Unit digit of 9 power n is not 1. Then what it can be? If it is unit digit of 9 power n cannot be 1, what it can be? We know the cyclicity for 9, right? This is only 2. That is 9 power 1 we have, then 9 power 2 we have, because 9 power 3 would go with this, 9 power 4 would go with this, right? This is one cycle, second cycle, 9 power 5, 9 power 6, etc. We talked about it. Okay, yeah, what is the unit digit of 9 power 1, which is 9? Okay, what is the unit digit of 9 power 2, which is 1? That's what we said, that the cyclicity for 9 is 2. It oscillates, all right? It swings between 9, 1, 9, 1, 9, 1. Good. So if it is not 1, not 1, the word is not 1. If it is not 1, then it is 9. If it is 9, the symbolic value of n is going to be what? The symbolic value of n is going to be 1. But the point is, here you may say that, sir, but the cyclicity for 3 and 7 is 4. Correct. Cyclicity for 3 and 7 is 4. So therefore, what you need to do, two test cases you need to consider. Case 1. So two test cases. What are the two test cases? One test case is with 1. All right, that's an important thing here. One test case is with 1. The other test case is with 3. Why? Because 5 will be equivalent of 1. See here. All right, no. So when you write here n, cyclicity for 3, you have 3 power 1, you have 3 power 2, 3 power 3, and 3 power 4. Same way you go with 7 power 1, 7 power 2, 7 power 3, and 7 power 4. Right? Same way you go like this as well. So what are the two prominent things? 1 and 3 comes in the picture. Why? Because if it is not 1, it has to be 9. If it has to be 9 means what? Either it can be 9 power 1 or it can be 9 power 3. You can say that, sir, it can be 9 power 5 also. Correct. But when I look at the cyclicity, I don't have to worry about 3 power 5, because 3 power 5 will be equivalent of 3 power 1 for the unit digit. I don't have to bother. I have to bother only till 3 power 4. Right. So therefore, I say the two test cases, either n can be 1 or n can be 3. right? You are trying to say that either n can be 1, which means this case is prominent, or n can be 3, right? N can be 3. From where I got that 1 or 3? From the 9 power, all right, from the powers of 9, right? 1 or 3. So I need to discard the other two facts. Fair enough. So add them. 7 power 1, this, what is the unit digit? 0, because it's a 10, unit digit is 0. Now add, get these unit digits here. The unit digit here is also going to be 0. Didn't get it, right? Now look at the unit digit of 3 power 3 here. 3 power 3 is nothing but 7. 3 power 3 is 3 power 3 is nothing but 7. Hey, what is the unit digit of 7 power 3? 7 power 3, the unit digit is nothing but 3. Add them, the unit digit is nothing but 0. Here also it is 0. I had two cases. There was a case 1 and there was a case 2. My answer is consistent in both the cases as 0. Therefore 0 becomes my answer for this particular question. Right, yeah, that kind of sets us with the revision of cyclicity. Two charts in the beginning of the discussion that we did. We should remember the cyclicity for which digits have the cyclicity of 4, cyclicity of 2 and cyclicity of 1. That is one chart that you might have to remember. The second chart is already we talked about, we talked about what is the unit digit of 4th power of an even number, unit digit of 4th power of an odd number. 4th power of an odd number. In all likelihood, I'm not saying that guaranteed, in all likelihood this would be 6, in all likelihood this is 1. There were exceptions. This is what the whole idea of the message for today was, and along with this I did some questions so that you kind of put these applications to perspective. Good. So that's the learning for today, and I will see you in my next lecture. I will see you guys tomorrow at the same time at 4 in the evening, and then bye till then. So as we get into the next year, that's probably we'll be doing the next lecture on 1st of Jan. So welcome back. So I will do you guys, we will do one of the interesting topic from the numbers. We will lay down this particular foundation as we go along, right? We'll solidify the foundation, then we will get ahead, then we'll go ahead and look at the intermediate stage of our preparation. Fair enough, guys. So this is where we go. So how do you reach out to me? Just in case you have doubts from any of these lectures, or any way that you want to reach out to me for short counseling or any suggestions, short suggestions, you can always reach through one of these particular Telegram channels, right? Yeah. And if you're doing it offline, etc., you can leave a short comment after the particular lecture. You can leave that comment. And if you have liked what we are doing, so you can always press the like button before you kind of leave the lecture. Right, so I will see you guys again tomorrow. Stay blessed. God bless you. God bless you. God bless you.